Hello and welcome to my YouTube channel Physics for All, and I'm Dr. Abbas. Today we will discuss the second method, that is known as substitution of variables. In our previous lecture we discussed about the method of separation of variable, and we highlighted the significance of separation of variables, that if we have a problem in x, y and in z, if we split them into x, y and z, we can solve it easily. But you will encounter a problem when you will be given some problems where you, if you want to split the terms given in x, y and z, you will not be able to split them. So here we will adopt another method to split these variables x, y and z, and we will solve them in the similar fashion as we did in our previous lecture. So for in first example, we have y prime is equal to y plus x over x. So I'm just going to rewrite it is as dy over dx is equal to y plus x over x. And I'm going to calling it equation number one. If you give a try to yourself and try to split this x and y, I believe you will not be able to succeed. So when you will encounter this kind of problem, what you will do, you will simply choose this y and put it as xv, the product of xv, or in other words, v is equal to y over x. By doing this, you will find after some steps, you will be able to split the given problem in the form of x and y as a new variable v. So when I choose y is equal to x v, then if I take the derivative here, I will have with respect to x dy over dx, as you can see here. And on the other side, this is there was simply product rule of the derivative, where I took the derivative of x. So dx over dx will give us 1, and we will come as it is plus the first term as it is x, and derivative of second, that is dv over dx. Now what we have to do, simply we will replace this dy over dx with this v plus x dv over dx, and this y with x time v. So when you will put this y is equal to xv here, you will find xv plus x over x. So here you have this common x, and you will have this x common. So in the next step, you can see I took this x common, and I will cancel this x with this x. So this dy over dx will be simply equal to v plus 1. Now I put the value of dy over dx, which is equal to v plus x dv over dx is equal to v plus 1. So in this case, on both sides, I'm going to cancel this v with this v. So what we have, x dv over dx is equal to this 1. Now I'm very close to say I can I can separate these variables v in the terms of v and x. So if I take this x on other side, it will become 1 over x, as you can see here, and this dx, it is divided, and when I will take it on other side, it will be multiplied, as you can see it here, and we will keep this dv as it is. Now what we did in our previous section, that we separated the variables, but here it was not straightforward to separate these variables, so we just substituted another variable v, and now we have been succeeded to split them separately. So the next step, as I discussed in previous lecture, that we will integrate them and we will find the solution in terms of y. So when you will integrate on both sides, we will have 1 over x, integral of 1 over x, and on the other side, we will have integral of this v. So here we have 1 over x, that is natural log of x, plus I will put some this uh, constant of integration, and on the other side, and I have this 1, and it will integral of 1 is v. So we obtained this natural log of x plus c is equal to v. But we are given the problem in the form of x and y. So I will put back this v is equal to y over x. So this will become y over x is equal to natural log of x plus this natural log of c. So here we had c. This is basically constant of integration. So to find the exact value of this c, actually we need to know the initial conditions that are not given in this problem. So we can call it, if we call it natural log of c, it will not matter. But uh, we need to find the exact value of this c, so it should justify the equation. So here our objective is to find the y, the output. So to do this sum can be replaced with this product by the log rules. And further, if I want to find this y, I will just multiply this x on other side, and we will have y is equal to x into natural log of c of x. So that is our required solution. Now we consider another example where I have y prime is equal to x square plus y square over xy. And here further we are given these initial conditions that describes that the value of y is equal to -2 when x is equal to 1. So in previous case, we find the solution with the in term of constant, because we don't had these initial conditions. Now we have defined these initial conditions in the problem. So we will try to find the value of this constant c as well. Okay, so let's start the solution. We can write it as dy over dx is equal to x square plus y square over x times y. If you try to simply separate x and y, you will not be able to do so. So what you have to do? You have to substitute this put y is equal to x v. By doing so, if you take the derivative, dy is equal to x dv over dx plus v. So now you will replace this dy over dx in the previous equation with x dv over dx plus v. And on the other side, where we had this x square plus y square, this y square is replaced with xv square. And in the derivative, in the denominator, we had this x times xv. This was xy actually. So here I'm going to take this x square common, and here we have x square as well. So this x square and this x square will be cancelled, and what we have here, when you will take this x square common, you will get this simply 1, and here you will get v square over x square v. So this x square is cancelled with x square. So what we have just v plus x dv or dx is equal to v square plus 1 over v. Now we are shaping this problem in the form of separation of variables. So we just put this x dv or dx on one side is equal to v square plus 1 over v, and we take this minus v from this side to this side. So here, when you will take this LCM v, you will get this v square plus 1 as it is, minus this v will be multiplied by this v, and you will get this minus v square. So this v square will be cancelled with this v square, and what we have, x dv over dx is equal to 1 upon v. Now in next step, you take this v on the other side, so it will become v times dv, and take this x, so it will this side it will become 1 upon x, and this dx will be multiplied and will become dx. So in this way, we have separated these variables by applying the substitution method. So now the next step, we just integrate on both sides. So we put the integral on both sides, and when you will solve this integral, you will get v square by 2, that is equal to 1 integral of 1 upon x is always natural log of x, and plus we put this constant of integration. So I want this v square, so I will take this 2 on the other side, and it will be multiplied with natural log of x and this c. So the new constant, I'm calling it c1, that is equal to 2c. Okay, so we had the problem in y and x, so I will put back this v is equal to y over x, so it will become y over x whole square is equal to natural log of x. I took this 2 on the power of, so it will become x square plus c1. Okay, so if you want this y square only, you will multiply on the other side this x square, so it will become y square is equal to x square natural log of x square plus c1 times this x square will be multiplied. So we want to find y, so you can take square root on both sides, so you will have y is equal to x square natural log of x square plus c1 times x square root. I have mentioned this one as 1 by 2. So this is not our solution because here we have this constant and I want to find this the value of this constant, and for that purpose I will use the initial conditions. So we had according to our initial conditions, we had at x is equal to 1, we had y is equal to minus 2. So we had this equation, put these values, and you will put these values minus 2 for y, so it will become minus 2 square is equal to this x square has become 1 square natural log of 1 square, that is always 0, is equal to c1 times this x, that is equal to 1. So this natural log of 1 is 0, so this term will be cancelled out, so minus 2 is 4, so c1 is 4. So put this value of the constant back in the term, so you will find y square is equal to x square natural log of x square plus 4x square. So simplify to find y, take square root on both sides, and you will obtain this solution. Okay, so for another example, if you want to practice, you can solve this problem by yourself. And if you have any questions, please ask me in the comments. Thanks.